Hi guys, today I'm going to be showing you how to set up a digestion. So we're going to be digesting a vector and we're going to be digesting a part for assembly. I already have my Google Docs spreadsheet up with the recipe for a master mix, and all that we really need for digestion is water, some buffer, and the two enzymes, or one enzyme that we're going to be using. We're going to be setting up 3 reactions. I've set my digest calculator to 4 because one of our reactions is going to be a double volume reaction. So we're going to be doing 2 10 microliter scale reactions and 1 20 microliter scale reaction. So it's pretty simple. All I got to do is pipette whatever it says in that little recipe into here. And that recipe is water, buffer, enzymes. So we're doing 4. That means we're going to be using 20 microliters of water, 4 microliters of buffer, 2 microliters of each enzyme. So, get my pipette. This is a P20, and I'm just going to get about 20 microliters of water. And this is pure water. The high quality boxed, double deionized, autoclave, everything special about it water. And set my P20 to 20. Pull up 20. Look at the pipette tip, make sure it's about 20. And I'm going to be making this master mix inside of one of these PCR strip tubes. So I'm going to eject my 20. And actually, before I continue, I'm going to slice up my PCR tubes. So I have a strip of 8. I'm only going to be using 3 of them. So I'm just going to count 1, 2, 3, and then slice at that third one. And then I'd set the other tubes aside. I might use them later. And then I can reopen it. Maybe. Oh my god, this just sucks. And we'll just go from there. So we put in our 20 microliters of water, and since it was just water, I can reuse this tip. So I'm going to dial it back down to 4 microliters so that we can put in our buffer. We're going to be digesting with BAM-H1 and ZO1. Both of those enzymes are compatible with buffer 2. If you're using anything else, you always want to Google your enzymes on NEB's website and check to make sure what buffer system you're using. So this is NEB buffer 2, it's blue, it has the number 2 on top. This is not to be confused with expand buffer 2, which is used for polymerase and PCR. So NEB buffer 2. This is a 10x buffer, so that means that you want to have 1 microliters per 10 microliter total volume, which means a 1:9 ratio. So we have 40 microliters in this master mix, so 4 microliters of this buffer. So we can kind of keep track. So we've added 20 and then 4, so that is, what is that, 24, I guess I can add. And then we're going to be adding our enzymes. So enzymes always need to be kept on the freezer at -20. And enzymes are very expensive, so whenever we bring them out of the freezer, we keep them in this little block. And I'm going to be using BAM-H1 and here is ZO1. So if they're not in the block, we keep our enzymes alphabetically ordered in these other big blocks. We're going to be adding 2 microliters of each enzyme. So there's a little bit of technique when you're pipetting enzymes. If you stick your pipette tip all the way in, then the enzymes will cool the walls of the pipette tip, which will cool the air, and then as we know, if we remember from physics, colder air is more dense and it will suck up more enzyme than you actually have your pipette dialed to. So you're only going to want to suck up from the top, and another reason why you don't want to jam your tip all the way into the enzyme is enzyme will stick to the outside of the wall, so you may be getting enzyme inside of your pipette tip as well as outside, kind of doubling or maybe even tripling your dose depending on how much you're trying to pipette. So it comes with a little bit of practice. You always want to keep your enzymes as cold as possible. So I want 2 microliters. I'm going to kind of move it to the side, move my tube to the side, and I can see right here the surface of the enzyme, and that allows me to stick my tip right at the top, give it a couple seconds, and then I drag my pipette tip along the inside of the wall of that tube to try to get rid of any excess enzyme. And that's 2 microliters of BAM, and I just flick any extras in there and change tips. And now we're going to do the same thing with ZO. So this one, the enzyme level is a little bit higher, so I need to come in from the top and as soon as I get in, I can see there's a slight distortion in the surface of the enzyme, and that's when I know I've gone in. Double check it, that's about 2 microliters. You'll kind of know more or less what microliters look like with experience, and eject. So, whoops. So now we have our water, our buffer, and our 2 enzymes. So that's 20 water, 4 buffer, that's 24, plus 2 of each enzyme puts us at 28. That's not the total 40 microliters, but this is the master mix, and all we have to do is add 3 microliters of each part in order to bring us up to our 10 microliter reaction. So I'm going to aliquot these out. I'm going to be aliquoting 7 microliters into each tube, and from our master mix tube into these 2 tubes, and then this master mix tube is going to be our double dose, our 20 microliter scale reaction. So set my P20 to 7 microliters. I'm actually going to lift this guy up. You can see the reaction or the master mix in the bottom. Stick the tip in there, and I'm just going to kind of mix it up a little bit. Glycerol tends to not want to go into solution with water or buffer easily. It will if you work it, but if you just try to pipette your master mix straight up, then you're going to get different amounts of enzyme and buffer and water in each reaction, and you're not going to get a good reaction, and you may not get any DNA actually digesting. So you always need to make sure that you really mix your reaction up really well, and that goes for any sort of enzyme reaction. That goes for PCRs, for ligations, for everything, because all enzymes are kept in glycerol. So there's 7 microliters in number 2, and 7 microliters in number 3, and then number 1 has 14 microliters left over. So I'm going to eject that tip. And now we want to add 3 microliters of our parts into our 10 microliter scale reactions, which are here and here. And then we have a 20 microliter scale, which is twice as large. So we're going to be adding 3 times 2, which is 6 microliters. So we're going to start off with our 6 microliters here, which is, we're going to be going for a PCR fragment. So 6 microliters. Check your volume, looks like about 6 microliters, and if I check that in, and I'm doing something very dangerous here, so learn from my example. I'm going into unlabeled tubes. You don't want to do that, because if I was to drop this, or if I was to walk away for a couple of minutes, I might come back and totally have forgotten what is what here. So we'll fix that in a quick second. And now we're going to want 3 microliters of our plasmid into those other 2 tubes. So I set my P20 to 3 microliters. So there's 3 microliters there. And I'm checking my pipette tip each time, just to make sure everything looks about right. 3 microliters. And then I'm going to cap. And again, in my head, I'm constantly repeating what's what, because I do not want to forget what is what. But we're just going to go with PCR, vector 1, which is going to be V1, and vector 2, which is V2. And now we have our reactions, and again, we have that same glycerol problem. So we want to mix our DNA up with that master mix. So I'm just going to give it a quick little flick, and you can see those beads moving around, and that's good. That's what we want to see. So just flick it a little bit, tap it down, and you can centrifuge this on a microcentrifuge if you want, but that gets about 95% of it down. So that's probably good enough right there. And then we're going to bring our enzymes back over to the freezer and put those away. And our actual reaction, tap it down one more time, is going to go into the incubator for 1 hour. So that's how you set up a digestion. We'll come back, we'll either run it on a gel or clean it up depending on what we need to do, and we'll proceed from there.